All right, there are a couple loose ends that I want to tie up here that we haven't talked about for a while, so let's start with this. This has to do with the project that I'm going to give you. And one of the things you're going to need to do is to calculate C epsilon r and C epsilon c from test results. Now, so here's a little example. This is the given information. You're given the points on the curve, and you need to calculate C epsilon r and C epsilon c. Quite simple. They're just slopes, right? So C epsilon r is the slope of this region, and C epsilon c is the slope of this region. So we all know that slope is a delta y over delta x, and so for instance, the C epsilon r is a delta y over delta x, and well, I'm going to take which 2 points? I'm going to take these 2 points, and so the delta y, we have 0.04 and 0.03 are the y's, and the x's are the 120 and 140, but of course this is a log, so it's the log of 120 minus the log of 40, and we know that the log of 120 minus the log of 40 is equal to the log of 120 over 40, and so we simply do this particular calculation, and that's what we get for C epsilon r, roughly about that. I'm going to let you do the rest of this. You can simply now use these 2 points to calculate C epsilon c for this particular curve. All right, another loose end I want to straighten up is finding UXS at points of interest other than the middle. Now, we actually haven't done this yet, and it's quite straightforward, but I'm going to do this little example because you're going to need to calculate this. So let's say we have a double drainage situation. In other words, I have this silt layer here underlain by sand, and that's the t equals 0 minus situation, and then at t equals 0 plus, I'm going to apply 4 meters of a sand fill at, gamma d for the sand fill is 20 kilonewtons per cubic meter, and C sub v for that silt is 1.25 square meters per year. And my goal here is to find UXS at depths 2, 4, 6, and 8 meters at 8 years. So how do we do that? Remember, we have to use this particular chart, and when we do that, that's the sink. All right. When we do that, the top of the silt is here. The bottom of the silt is here. And what we find is that we need to find our capital T, and we're going to go into this chart at various depths and read off on the correct T curve. And so we're going to we're going to start with finding our HDR. Since it's double drainage, it's H over 2. The H is what? The H is 10 meters. So we get 5 meters for our HDR. Then we're going to find our UXS at t equals 0 plus. Well, what's that? If you remember, the whole key, or one of the things you have to do to get this, is that the UXS at t equals 0 plus is due to the weight of this fill. And in this case, we have 4 meters of it at 80 or 20 kilonewtons per cubic meter, which means that what? 4 times 20 is 80 kilopascals. So that's my UXS at t equals 0 plus. So let's look at our depths to the point of interest. Those are given to us as 2, 4, 6, and 8. The time is at 8 years. We know that capital T is C sub VT over HDR squared. So I plug in my given C sub V. It was given as 1.25. The T is 8 years. And HDR is 5. So we square that. And we get that what we're interested in is dimensionless time factor of 0.4. That means we're going to use the curve at 0.4. Or in this particular case, I've got the actual curves here. I'm going to use this curve, which is t equals 0.4. And then I simply, now there's my top of the sill, there's my bottom of the sill. I'm going to break it up but to scale. So in this particular case, this is my top of the silt, this is my bottom of the silt, and there's my 0, 2, 4, 6, 8. So I just come in at the various depths that I'm interested in. So in other words, you've got to break this up to scale. It's not always going to be 10. It just happens we have good numbers, but you're going to have to break that up yourself. So, I come in here at 2, at 4, at 6, and at 8, I go to my curve and I read off the values. So you can see there's symmetry here because it's double drainage and it's symmetric on top of the bottom. So just showing these two. So I have this one, I read it down, 0.28. This one, I read it down, 0.43. And the others are, these two are similar. So I get that at 2, it's 0.28, 0.43 at 4, 0.43 at 6, 0.28 at 8. And then I simply take this factor times the 80, and I get the UXS at 8 years at these points that are not at the center. Okay, I'll stop there.